Everyone else is, multiple choice. Yeah. Oh, okay. Did you log in? Yeah. Cool. Okay. So you also I can print you off test 2 if it doesn't work. Okay. So you typed in your username and password like you would, and it still didn't work. Try it one more time and then let me know. All right. And you had a question on 2B. What number did you have?
Number 8.
Number 8. Let's take a look real quick. Number 8. Okay, so number 8. All we want to do is we want to add like terms. Grab a Chromebook when you get settled and go back and grab one. Cool? So I'll come over. All right, on problem number 8. Can I drop the parentheses? I have nothing on there yet.
You may.
So the parentheses, there's nothing in front, so basically I'm distributing 1 over the top. There's a 1 out here, distributed over. There's a 1 right here, distributed over. And these signs are both positive, so none of the signs have to change inside. Like terms, remember, either are numeric values or they have the same letter. So those are the same letters, so I have 4x and 2x. If I combine those together, I get 6x, right? I have 3y and 7y. If I combine those together, I get 10y. And then combine those two together, it gives me 8. Now, is the order really that important? You could have had 8 plus 6x plus 10y. You could have 10y plus 6x plus, the order is not important as long as you have the correct sign preceding it. And they all happen to be positive on this one. Is there any other questions that came from 2B? We want to take a look at. You good? No? Number 30, so it's on the back side? Okay. All right, number 30. We have negative 80x plus 9, parentheses 9x minus 4. Okay, so again, we're simplifying. So what am I going to distribute over the parentheses? 9. The 9. And it's a positive 9, so it won't change any signs. So this goes here and here. So the negative 80x comes down for the ride, plus 81x, and then minus 36. Did I do that right? So notice the 9 times 9x, which is 81x, and then 9 times negative 4, which is negative 36. My like terms have the x's, so if I combine those together, I get 1x, and 1x is the same thing as x, okay? So x minus 36 is my answer. Any other questions from worksheet 2B? Yeah? 32? So I have a half out front, and then 12 minus 30d. What am I going to distribute over the parentheses? 0.5 or half. Okay? So half of 12 is 6, or 12 over 2, and then reduce it. And half of 30 is 15. Make sure you keep it minus, because there's minus there, so I get 15d, and it's done. You also could have negative 15d minus or plus 6. That's correct, or that's correct. It's your choice which way you'd like to do it. Yeah. How much? 3? Number 3, we have 2 minus 5y, parentheses negative 3. So this is kind of a flip-flop of distributive. They just have what you're distributing over on the opposite side. So I'm going to distribute negative 3 here as well as here. So negative 3 times 2 is negative 6. Negative 3 times negative 5y is positive 15y. So this answer is totally right, or you could have the answer this way by maintaining the signs. Your choice. Okay? Yeah. 14. 14. We have 7 plus 1/5. 20x minus 10. Is everybody still with me on this one? You okay? All right. Okay. Let's see. John Adams? Pass that back. Jail. Pass that back. Joseph. That's you. Don't pass back. Maddie Nash. Pass that back. Charity. And Charity again. Perfect. I think we're good. All right. Oh, we're distributing the 1/5 here and here. So 7 comes down plus 1/5 times 20. That's 20 over 5. How many times is 5 going to 20? 4. So I get 4x. Is that okay so far how I did that? And then 1/5 times negative 10. So I know it's going to be negative. So negative 10/5 is 10 over 5, which is negative 2. What are my like terms? 7 and the 2, so we're just going to subtract them, so I get 4x plus 5, or I could have 5 plus 4x, your choice. 15? Yeah, buddy. Do what I can, press. 15. 1/2, 12n minus 10 minus 2n, and we'll have some more time to go over some more of these later, so this will be my last one for today, okay? So I'm going to distribute half over the parentheses, so half goes here and half goes here. What is half of 12n? 6n. What is half of 10? 5, and it becomes a negative, right? And then minus 2n. What are my like terms up there? 6n and negative 2n. If I combine 6n and negative 2n together, I get 4n minus 5. Done. Good? Everyone feel comfortable? Sweet. Clear your desks. Calculators work. What? Actually, just don't erase it. Just grab a tissue rather than use your hand. All right. So we're going to take a quiz today. There's 2 portions to it. I'm going to hand out both, one part's going to be on Schoology. It's not active yet. I have not activated it. I will. And then this is the pencil and paper portion. Okay? You need to do both portions. Still with me on this? So I don't care if you do this portion first, Schoology part second, do a little bit of both. Your choice. Okay? But I will activate it on Schoology here in a second. All right, here we go. So we're starting to solve equations a little bit. So there's 1, 2, multi-step. Sometimes it could be 2 steps, sometimes it could be one step. This is actually called the 2-step equation because you do 2 different things in order to get there. Okay, you're trying to solve for x. Now the hard thing about doing a lot of these types of things is you might think you can do it in your head. I agree. But a lot of times, what happens if you give an answer only on a test, I can't see the thought process that takes place. So an answer only, if it's wrong, means if the problem's worth like 3 or 4 points, you miss all the points if it's wrong, if there's no work shown. The thought process has to be shown. If it's not, and you miss it, you're in trouble because you're going to miss more points than, if you miss 1 point out of 3 points, that means you got 2 of those points for the problem. But again, if you don't show your work, and it's wrong, you miss all the points. So, what you do to one side of the equal sign, do you do to the other? So I'm going to draw that vertical line in there. That's going to represent the, what sign? Equal sign. Equal sign. What do I do to one side of that, I have to do to the other. Still with me? Okay, so I want x to get along. So I have 5x minus 2. So I'm going to start, and I'm going to subtract 2 from both sides. Okay? So in order to say equals, it means it's balanced. So what happens to one side of the equal sign has to take place with the other side. Does that make sense? So does everyone feel comfortable that this and this are gone now? Yeah. What's still left on this side of the equal sign? 5x. What's going to be on this side of the equal sign? 5. Is that okay? A 5? Okay. Hey, how are 5 and x being held together right now? What math properties hold them together? Multiplication. Multiplication holds 5 and x together. Do you agree? Yes. What undoes multiplication? Division. So what am I going to divide each side by?
5.
Okay, good. So if I divide each side by 5, so this cancels this. Agree? What do I have left on this side? X. So X is equal to what?
1.
Good. Done. Okay? So not all of them will be that extensive. In fact, tonight you probably won't have multiple steps. Can I move to the next screen?
Yes.
We okay? All right. So I'm actually going to move to this one. I'm going to go to there. Don't worry, just strike through it if you wrote down. So how are X and 6 being held together at this point? By division. So I'm going to put that represents what? An equal sign, you agree? Okay, so what I'm going to do from there is X and 6 are being held together by division. What is the reciprocal property of division? Multiplication. So what do you feel I should multiply each side by to get X all alone? 6. So I'm going to multiply this side by 6, and I'm going to multiply this side by 6. What happens with this 6 and this 6? They cancel each other out, leaving yourself just 1x, and 1x is? 1x is?
Negative 12.
Is x equals, and so on, just step forward. These are being multiplied, right? I had to multiply both sides by 6, so negative 2 times 2. Negative 12. Done. Okay. So x is equal to negative 12. Meaning if I were to take negative 12 and plug it back into the original equation, my answer would come out to a true statement. I'd wind up with, like, in this case, negative 2 is equal to negative 2. Huh? Well, the original problem was this, right?
Yeah.
So if you were to take this, put that there, right in this region, you get negative 12 over 6. Is that equal to negative 2? And the answer would be yes. That checks. Yeah, that means that's the answer. Okay. May I move on? Feeling okay? Okay. And guys and girls, I thank you so much for being flexible and making this work. Yeah? What if you had a number by X? Ooh, we're going to get there, I think. Like that? Oh, sweet.
Like a fraction.
Like
a fraction.
Oh, we're going to get there. We're totally going to get there.
Okay.
We're totally going to get there. All right, so negative 3 times X is equal to 18. So how are negative 3 and X being held together right now? By multiplication. So what undoes multiplication? Division. What is this? What does that dotted line mean? It's my equal sign. So what I do to one side of it, I have to do the other. So these are being held together by multiplication. So what I'm going to do is I'm going to divide each side by negative 3. So that means this and this cancel out. Still with me? What do I have on this side? X equals 18 over negative 3 is what? Negative 6. Make inside. Oh, I'm tripping. Good. You guys laugh when people fall. I love it. Yes. May I move on?
Yes. You may. You may.
Is this what you're asking about? Ooh, I have 2/3 times the number is equal to negative 24. Excuse me. Okay. So 2/3. So what do I have to do with this type of thing? So let's do things we know. That's what? What does that mean? Equal sign. So what I do to one side, I have to do the other. Still with me?
Yeah.
All right. All right. So 2/3. What I want to do is I want to do the reciprocal of 2/3. What is the reciprocal of 2 over 3? 3 over 2, right? Right? The reciprocal means you just flip it over. So what I'm going to do is how are these two being held together right now? Multiplication. So what I'm going to do is I'm going to multiply both sides by the reciprocal. Now hang on, time out, time out. You said if this times that, I have to use division. But now you're giving me this new word called reciprocal. Okay? So listen to me carefully. Ready? Multiplication and division are reciprocal properties of each other. Okay? So technically what I'm doing on this problem is I'm dividing this by 2/3 and this by 2/3, which looks pretty complex. But you remember your concept of fractions? When you're dividing two fractions, you have to change it to multiplication, and you flip the one over on the right side. Copy dot flop, right? Copy dot flop is the same thing as multiplying by the reciprocal. So copy dot flop, so I'm going to multiply by 3 over 2 and 3 over 2. And what happens here is this 3 reduces here. This 2 reduces here. So what do I have on this left side? An x. An x is going to be equal to, a couple ways I can do this. I can say, well, 2 goes into 24 12 times. Don't forget the negative. And then negative 12 times 3 is negative 36. Okay. Copy dot flop. Like it. We feeling okay?
Yeah.
Like that? How about that? All right. What is my reciprocal of negative 5/3? Negative 3 over 5. So let's put our thing we know. Whoop, it's in there. I'm going to multiply this side by negative 5 over 3. Oh, 3 over 5. My dyslexia kicked in nicely. So, negative and negative, what do you know? It's positive, that's okay. This side is going to change to become a negative, do you agree? So that 3 reduces with that 3, that 5 reduces with that 5. What do I have on this side? X. All right. What do you definitely know my answer is going to be on this side? Is it going to be positive or negative? Negative. All right, so we're good there. Okay, so 30 times 3 is 90. 90 over 5 is some number. Or you can go 5 into 30 is 6. 6 times 3. And we knew it was supposed to be a negative answer, right? If these were both negative, then it would have been a positive. Yeah.
Since you're dividing 30 by negative 5,
But you remember what I said? What's the sign going to be on this side? We took care of it, so we took care of that sign already. Is that cool? So I was just trying to get our signs down, because signs goof up people quickly. And I honestly, in some workforce field, you're not going to be dealing with all these negative numbers. It's going to be pretty obvious. So why do we do it? Because it's brain development. That's why. Yeah.
Would there be like a question with the variable on top of the number, or like a number on top of the variable?
Like this. Oh, like this.
Yeah, or like vice versa.
We will get to that. This is division, so you just multiply each side by 3. This we will get to at a different time, so let's not stress about that yet. Is that okay? Yeah.
What about something like 5x over 6, and then like equal
5x over 6, then you multiply by 6 over 5.
Okay.
So that's the same. So that would be like this. This is actually the exact same problem as what we just did. It's just we're putting the variable up in the numerator rather than off to the side. We okay? All right. So let's kind of coordinate a few things that we're going to be good at. So worksheet number 2B. This is kind of what we did last night, right? So this will be due tomorrow, which is Thursday, yes?
Yes.
I'll get the Schoology thing fixed, so we will do the thing on Schoology tomorrow. But then also, what we will start working on is worksheet number 3, which is page 9 and 10. Hang on. So this is pages 9 and 10. So this right here will actually be due on Friday. So let's do this. Focus to make sure this is done. And then I will tell you that the quiz on Schoology that you will do tomorrow will not take you all that long to do. So then make sure you bring this to class so you can, once you're done on Schoology, start working on this, because tomorrow I'll collect worksheet 2B. Friday then I will collect this. So if you want to get a start on it, you're always welcome to. I mean, you got to budget your time, yes? That's all I'm asking you to do is just budget your time. So if you know that tomorrow is a really busy day for you, it might be good to start on this and then saying, sweet, I probably will have some time during class to work on it as well. Okay? We good? Guys and girls, I can't thank you enough for being flexible with the Schoology quiz. I mean, I have part of it done. Cool here. But we'll make it work. I mean, sometimes technology gets goofy, and then maybe we'll figure out if we can get your Schoology working as well. We'll figure that out, all right? So, cool. I can't thank you guys enough. It was awesome. Everything else going okay? Let's not line up by